Okay, so just going through one sample question here on refractive index. So light is incident on a glass block of refractive index 1.5 and at an angle of 35 degrees. Now, we're assuming that 35 degrees is taken off the normal line. Remember, that's the normal line there. I think it's always worth sketching a picture. It takes like 2 seconds to do it. If you sketch a little picture of medium 1 and medium 2, out here we've got air and here we've got the glass, okay? And it's always worth having a little picture. So question A, calculate the angle of refraction. So let's try that now. So in order to calculate the angle of refraction, I'm going to use our formula, Snell's law, which is the sine of the angle of incidence divided by the sine of the angle of refraction should be equal to the refractive index. Now you can basically do a quick swap here if you like. Okay, these two guys can just basically switch places, and that will give us the sine of the angle of refraction equal to the sine of the angle of incidence divided by the refractive index. So then the sine of the angle of incidence is the sine of 35 degrees divided by the refractive index, which is 1.5. So this works out to be the sine of the refracted angle turns out to be 0.3824, we'll say. So that's the sine of the angle, and now what I do is I take the sine inverse of both sides, and that gives me the angle of refraction. Of course, if you're a little bit confused about that, please go back on the other page on using the sine function. So I'm taking the sine inverse of the ratio, and that works out to be 22.5 degrees, we'll say. 22.5 degrees. Okay, so hopefully that makes sense. Part B asks, at what angle would the light emerge from the other side of the block? We've decided to include a picture with this question. But like I said, I really encourage everyone to sketch a picture of a standard experiment or whatever the situation is before you try to answer it, because the picture clarifies what's going on in the question. So the emergent light, well, this is the incident light, goes in on that side. It's refracted in here, and it's emerging on this side. Now, we don't have a normal line here, but you can probably guess that this angle is going to be the exact same angle here as it would be when it came into the block, before it came into the block originally. So if it came in at 35 degrees, then it would come out also at 35 degrees, off the normal. Okay, that's off the normal that you draw at the point where it emerges, because in the experiment that's how you do it. The last part of the question that I decided to add to it was to calculate the critical angle for the light going from the glass into air. So in order to calculate the critical angle, again, you're going to use, it's the same formula actually, it's just looks slightly different. So the sine of the critical angle is 1 over the refractive index. We know that the refractive index is 1.5, so 1 over 1.5 that works out to be sine of the critical angle is equal to 0.667 recording, and then the sine inverse of that quantity. So if you're looking for the critical angle, again you're taking the sine inverse of both sides, and that gives me sine inverse of basically 2/3, which works out to be 41.8 degrees, and that is the critical angle for class, and it's worth trying to remember that number. You really only have a few materials that you need to remember the critical angles for. At least you should have a good idea. So if you get them wrong, or if you get an answer in the exam, it should look pretty familiar to you. Okay. Try the examples below